Good afternoon, and welcome to the Future Energy Supply Chain for Zero-Emission Bus Fleets, Hydrogen Integration Across Canada for Transit Fleets. My name is Mark Kirby, and I'll be the moderator for this session, and I'm joined by a distinguished panel, which I will introduce. We have Mr. Nicholas Pocard, who is the Director of Marketing for Ballard Power Systems. We have Mr. Steve Kay, who's the Manager of Business Development with Enbridge. And we have Mr. John Quinn, Senior Manager for Renewable Gas Supply with Fortis. And we'd like to start by saying a big thanks to Josipha and the CUTRIC staff for the fabulous job they're doing in organizing this great event, and our thanks for being able to join today. As mentioned, my name is Mark Kirby. I'm the President and CEO of the Canadian Hydrogen and Fuel Cell Association. And before we get underway, I'll take just a minute to say a little advertisement for the CHFCA. We are a nonprofit based in Vancouver, and we represent Canada's world-leading hydrogen and fuel cell sector. We are the voice of the sector, working on things like marketing, communications, events, projects, and advocacy. And I encourage you to check out our website, www.chfca.ca. The detailed bios of all of our presenters are online, so we'll encourage you to check those out. But right now, what I'd like to do is get things underway, and we'll start with Mr. Nicholas Pocard.
Thank you, Mark. Good afternoon, everyone. Bonjour. Ici Nicolas Pocard chez Ballard Power System. I'm very happy to participate to the CUTRIC conference today. And what I'd like to talk to you a bit about the supply chain for fuel cell electric buses here in Canada and where we are. But just as an introduction, I would like to just present one slide. Make sure maybe not people have realized that is that there are thousands today of fuel cell electric buses on trucks and trains which are powered by Canadian fuel cell technology. Companies from Ballard or Hydrogenics or Loop are today involved in many projects worldwide, and fuel cell electric vehicles are being deployed. Not a lot in Canada. Out of the slide here, I think we have only one project in Canada for fuel cell trucks in Alberta. Very interesting projects for heavy-duty mobility. And we hope that we start to see, maybe adoption here in this country. And that's a bit of a paradox because it all started here in Canada. At Ballard, we put the first fuel cell bus on the road in the late 90s, which actually was the first electric bus ever built in the world. It started here in Vancouver, Canada. We have been a long way since that, so we have more than 20, 30, 25 years of experience of building, developing the technology for fuel cell electric vehicles. And so today, we have accumulated over 20 million of kilometers for the vehicle which are currently in service. There are over 3,000 fuel cell electric buses on the road in North America, Europe, and China. And today, the availability of a fuel cell system in a fuel cell bus is above 97%. And the availability of the vehicle is between 85 to 90%. So very similar to internal combustion engine vehicle. And today, we see numbers of bus OEMs offering fuel cell as a standard option for their electric bus platform. But what is unique, what we have here in Canada, is we have a complete value chain for hydrogen and fuel cell buses, starting from the components level at the fuel cell side with manufacturers like Ballard making fuel cell systems here in British Columbia, hydrogen storage tanks, as well as also all the components of the electric drivetrain with companies like TM4, Dana, Linamar making all the components of the drivetrain. Bus OEMs like New Flyer today offer a complete range of 40-foot or 60-foot transit buses. And it goes also into the hydrogen supply chain, from the production of hydrogen electrolyzers, company like Hydrogenics. We have in Canada production of hydrogen, distribution of hydrogen, as well as dispensing. We have engineering companies and specialize in like H-Tech in the hydrogen refueling station for light duty and heavy duty. So we have a unique opportunity here in Canada to have a complete supply chain and a value chain to deliver the most value to the Canadian economy. Here is just I'm a member of the board of CHFCA, and as you can see, you have a really numbers of companies all across the country from coast to coast, which are part of this hydrogen and fuel cell supply chain, making all the elements of the technology and the energy here in Canada. And as my last slide, I would like to finish a little bit about, why fuel cell electric buses make sense here in Canada. First of all, I think fuel cell electric buses today are commercially available. They are suppliers of buses as well as hydrogen systems and hydrogen molecule here in Canada. And if you look at the total TCO, total cost of ownership of the vehicle and the infrastructure at scale, fuel cell electric and hydrogen is competitive with other clean transit alternatives. We have seen this morning in the conference, there was a number of challenges with winter in Canada with electric buses, and we believe that fuel cell and hydrogen provide a really good solution to address those climate conditions. But at the end of the day, we believe that we need both. We need battery electric and fuel cell electric buses in order to enable 100% zero emission transit in Canada. Low carbon hydrogen can be produced in every province using our local natural resources, hydro, wind, in order to really reduce the GHG of the fuel. We have, as I mentioned, a strong ecosystem in place, and we believe that the deployment of fuel cell electric buses will also pave the way for other heavy-duty applications like truck, marine, or rail. Thank you.
Thank you, Nicholas. Appreciate that. It's impressive to see the breadth of experience and the skills that are in the Canadian industry. Next up, we have Mr. Steve Kay.
Thanks. Good afternoon, everyone. I'm Steve Kay with Enbridge Gas. I've been with the company for 28 years and currently lead a group responsible for developing lower carbon energy markets, including hydrogen, compressed natural gas, and liquefied natural gas. Hopefully you all are coping well in these unprecedented times. Personally, I'm a bit nervous with this video call. It's my public debut of the beard that I've been growing since the COVID lockdown began. I should also caution everyone in advance that I'm a business development guy. I'm not an engineering guy, so I may be a little light on the technical details. Next slide, please. Maybe I'll be able to do it here. Oh, there we go. Many of you will be familiar with Enbridge Gas as your friendly neighborhood Ontario gas utility, but our operations are actually much broader. Our parent Enbridge Inc. is a North American leader in delivering energy. Our purpose is to provide safe, reliable energy that fuel people's quality of life and the North American economy. Our liquids pipelines transport about 25% of the crude oil produced in North America. We transport about 22% of North America's natural gas. We deliver 40% of Ontario's energy requirements, and that includes electricity in that calculation of energy requirements. We also have 23 renewable power facilities powering over 700,000 homes. And most importantly for today, we developed North America's first utility scale power to gas facility. Next slide, please. So power to gas is a process of taking ideally low carbon clean electrical power and through the electrolysis of water, converting that power into its gas constituents of hydrogen and oxygen. Now, our power to gas plant in Markham, Ontario is a joint venture with Hydrogenics. It's currently under contract with the IESO to provide balancing services to the Ontario power grid. Now, although we're under contract with the IESO, we do have excess hydrogen available for the market. At peak output, our plant can produce up to 1,000 kilograms per day of high purity renewable hydrogen through electrolysis. Next slide, please. So there are many potential markets for the hydrogen produced at our power to gas plant, and we're active in all of these markets. The focus of today's discussion, of course, is providing fuel for fuel cells to power zero emission vehicles. Next slide, please. So this slide just provides examples of how much transportation energy can be provided by 1,000 kilograms per day of hydrogen, which is our plant's current output at peak capacity. You can see that 1,000 kilograms could provide a 250 kilometer range for 50 fuel cell buses every day. Next slide, please. So hydrogen's got great potential as a clean energy source for the future. Some of the challenges we see in the near term are the lack of supportive policies from government that can attract and de-risk private investments and really help with smoothing the expansion of capacity to balance supply and demand. You know, some jurisdictions like Germany have been developing comprehensive national strategies really to support market growth. Here in Canada, Enercan's initiated some foundational work that could be built upon further. In terms of examples, some more specific and challenges include things like access to clean and low-cost electricity for electrolysis, given its significance in operating costs, reducing the distance between supply and demand locations to minimize transportation costs, and guaranteeing a large enough market with sufficient term duration to achieve economies of scale. It's not intended to be an all-inclusive list, but it's some of top-of-mind items for producers of hydrogen. With that, I will pass it back to our moderator.
Thanks, Steve. Appreciate the overview of what Enbridge can provide, and also that very interesting project in Markham for producing hydrogen. Last but certainly not least, we have John Quinn.
Thank you, Mark. Fantastic presentations by Nicholas and Steve. I guess what I'm going to go through here will be from the utility perspective. So some dovetailed with Enbridge's presentation just now. So to introduce myself, pleasure to meet everyone virtually today. My name is John Quinn. I'm Senior Manager for Renewable Gas Supply at Fortis. What I'm going to speak about today will dovetail a lot into our low carbon transportation business and knit together our plans for hydrogen in the future and how that will link it to our growing low carbon transportation business. Next slide, please, Mark. Just a little bit about Fortis. Fortis BC Energy Inc. It's a subsidiary of Fortis Inc. Fortis Inc. is headquartered in Newfoundland. Fortis BC Energy is the British Columbia subsidiary. Serves about 1.2 million customers in 135 communities throughout BC, highlighted in our gas customer service territory in the light blue on the map on your screen, electric service territory, the shade of green. Investing in infrastructure on an annual basis between $500 million and $1 billion. Everything from pipeline to LNG to power generation. All in, Fortis BC Energy Inc. delivers about 21% of BC's energy needs, including electricity, natural gas, renewable natural gas, which directly relates to my role and responsibilities in our organization, compressed and liquefied natural gas, primarily for transportation markets, and alternative energy solutions. Next slide, please, Mark. Thank you. In terms of low carbon transportation solutions, our low carbon RLCT business, Fortis has invested approximately $700 million in various different values of the supply chain that supports that business. Investments include in refueling infrastructure, so that's compressed natural gas, liquefied natural gas, and EV charging. LNG production infrastructure to feed that supply chain, and also renewable natural gas. So the renewable natural gas is a drop-in fuel for natural gas, and our compressed natural gas customers can avail of our renewable natural gas supply as a low carbon fueling solution for their transportation needs. Next slide, please, Mark. I like this slide. It's an interesting snapshot of the players or our low carbon transport customers that we have built over the last, I think, approximately a decade. So right now, the Fortis low carbon transport business supplies fuel to about 800 heavy duty vehicles And I think up to maybe about 10 of those are in the marine sector, both onshore and large offshore vessels. Just want to make a couple of important points here and dovetail back into what maybe Steve was mentioning in terms of how this business was grown over time. And it was certainly built on the back of some very forward-thinking policy in BC, such as the greenhouse gas reduction regulation. That's key for Fortis's renewable gas and transport business, and that enables Fortis to acquire low-carbon renewable gas, for example, and also invest on the opposite side of the value chain in refueling infrastructure and incentives for operators to bring OEM equipment, such as natural gas and LNG-fueled vehicles, onto the roads. A lot of support from Enercan as well in terms of supporting the refueling infrastructure that Fortis has in place to make this business work. Next slide, please, Mark. Thank you. So this is I like this model. It's like a practical realization of the Fortis low carbon transportation business. It sort of knits together the different low carbon fuels, including compressed natural gas, liquefied natural gas, and you can see hydrogen is highlighted as well. And this is Fortis's unified or multi-fuel refueling hub. So you can see there's a transit bus pull in, and you can see the color coordinated EV charging, CNG, and hydrogen. So in the future, as we work with government to develop policy in BC and expand the greenhouse gas reduction regulation, we see hydrogen, both the production, the delivery, and working with customers to bring hydrogen vehicles on the road, part of our future low carbon transportation business. And we see the various pieces of that bolting nicely onto our current business model. Next slide, please, Mark. I think this is my last slide. So just to finish off, conceptual look at a potential model to support hydrogen infrastructure projects moving forward in the transportation sector, which we're going to discuss later. So Fortis has proven ability to finance, own, and operate low carbon refueling infrastructure, as I mentioned. Previous experience in owning and operating CNG, LNG infrastructure for projects. Deep utility experience owning and operating power and gas distribution and transmission assets, and a well-established and reputable company with local presence. So all of this will come together to build on our current experience and dovetail hydrogen as a value stream, as a fuel source in a low carbon transportation business going forward. That's my slide deck. Thank you.
Well, thank you, John. It was interesting to hear your comments on policy, and we'll come back to that in a bit and ask some more of your opinions on policy and the role of government in moving forward hydrogen and hydrogen energy. But I'd like to start off first with Nicholas, and a question for you. Nicholas, you've been selling to transit agencies for many years in many countries, in Canada, around the world, and there's an impression that many transit agencies are still opposed to the whole idea of hydrogen as a legitimate, fuel for their fleets. Is that true, and are you seeing that changing in Canada? You'll need to unmute yourself first.
Okay. Yes. Can you hear me now? Yes. Thank you. It's a really good question. I think as I mentioned earlier, it all started in Canada. And maybe in a way, maybe started a bit too early, at the stage when they put the first fuel cell buses on the road in British Columbia and Vancouver and later in Whistler. The vehicles were very expensive. There were still some, technical, immaturity in technology. It was, 10, 20 years ago. If you remember where a battery electric bus was at that time, we couldn't even put them on the road for less than 50 miles. But I think what I think is changing. I think, first of all, people are realizing that a hydrogen bus is an electric bus. 90% of the components are the same. I think at the end of the day, it's more about how you're going to bring the electron to the vehicle. Do you store them as a battery or do you store them as hydrogen? And how are you going to manage your energy storage or energy recharge? So I think I think people start to realize that the vehicles are roughly the same. But I think as an industry, there's three things we need to do. First, and I think this is done, we need to prove that fuel cell works. And if you heard this morning, the experience of OCTA and Sunline and many others in Europe, nobody doubts that the technology works. But I think we have two challenges that we need to address here in Canada. First of all, we need to be able to deliver low carbon hydrogen to the transit agency across the country. Without the supply of low carbon hydrogen, then we have an issue. So in some parts of the country, it's available today. It's not available everywhere. So we need to work with the ecosystem. We need to work with our partners like FortisBC or Enbridge to make sure that we can deliver that low carbon hydrogen across the country to the transit agency so they can really move to hydrogen and reduce the emission. And on the last point, it needs to be affordable. I think there's still a perception that fuel cell buses are very expensive. However, when you look in California, the latest government procurement, the price delta between a battery electric bus and a fuel cell electric bus is only 15%. So on a vehicle, but now if you look at the overall cost of ownership, including the infrastructure, the depot, the operation, everything, then the delta is gone. And I think it was very interesting to read the comment this morning from both Lauren at Sunline or OCTA saying at scale, whenever you scale up hydrogen infrastructure, the cost become cheaper per vehicle than electric infrastructure. So I think it's very important not to look just at a couple of vehicles, but to look at the scale, to look what it will cost to put 20, 50, 100, a full depot, and then do the cost calculation for that. And then this is really where fuel cell or hydrogen as a fuel delivers its most value. So I think as an industry, we need to show that. We need to show that we can deliver that low cost, low carbon hydrogen. And then you really work on the total cost of ownership, including not just the vehicle, but the infrastructure in order to operate the vehicle.
Thanks, Nicholas. And so, turning now to John, you've been selling to the bus agencies for a while. Would you agree with Nicholas? What is the main barrier? What are the things that have caused the reluctance, perhaps, for agencies to adopt hydrogen? And you'll need to unmute your.
There you go. Little red line off the microphone. Hopefully it's working now. You're correct, Mark. So Fortis, we do supply compressed natural gas fuel to transit agencies, and also where those customers would like to acquire renewable natural gas, we can also supply that. It's a drop-in replacement fuel. In both cases, they're very economical fuel supplies for customers to use, or even fuel switch from diesel, for example. Mark or Nicholas, I think brings up a very important point in terms of affordability. So I think in terms of the production of hydrogen, the industry will need to focus on ways to supply the lowest cost hydrogen possible. In the near term, I think distributed production of hydrogen, at least power to gas, seems to be the, let's say, easiest to get off the ground, but that will be, in terms of affordability, I would say, heavily dictated by the price of the feedstock, which is the electrons that go in the front end. I know right now in Fortis, as we start to examine our production pathways for hydrogen with a view to incorporating this in our future models, we are looking at ways to use technology to generate hydrogen from natural gas coupled with carbon capture, and there are some unique proposals in some medium stage TRL levels, but would be very suitable in the future for distributed co-located production of hydrogen beside commercial markets, such as a growing transit fleet or medium and heavy duty fleet in urban centers.
So tackling that question of hydrogen, I'm assuming that we're all sort of on the same page that we need to get low carbon intensity hydrogen to supply our municipal transit agencies. But what about the ongoing question about blue and green and purple hydrogen? Steve, can you talk? When you look forward, what do you see as the mix of hydrogen supply? The hydrogen strategy for Canada is going to be released over the next month or so, and rumor has it that it will have regional blueprints particularly around hydrogen production, taking advantage of the energy resources for each region. Should we be insisting on low carbon intensity hydrogen for public transit? And blue-green, does it matter? How do we put that to Steve?
Yeah, thanks for that, Mark. Yeah, it certainly matters. We want to be as green as we possibly can, but really I think both will need to coexist for a period of time, really to allow the market to grow efficiently. But barring any, technical breakthroughs, I think the longer term path will need to be green hydrogen and likely electrolyzed hydrogen, is my view.
And John, how do you feel about that?
I feel super about any color of hydrogen. I do believe there are multiple pathways and technologies that will emerge that will, leaving color aside, if we establish through policy or otherwise a carbon intensity for hydrogen, we set a limit and technology can achieve that and prove to achieve it and deliver an economical hydrogen fuel supply, I think that should win out, right? Yes, I guess I'll leave it at that, Mark.
And Nicholas, your view from the outside and looking at this, and do you see that there's a path forward for all types of hydrogen supply?
Yeah, absolutely, and it will depend on the location of the resources. I think the answer will be different in Quebec and British Columbia than it's going to be in the prairies. And it's all about also, access local resources. What is the best way to convert those local resources into low carbon hydrogen? And actually, there are technology being developed, in order to use natural gas and with carbon sequestration and also technologies to really reduce the carbon intensity of natural gas produced hydrogen.
Okay. So now stepping back, looking at today, if you're a transit agency and you wanted to start putting hydrogen buses on the road, or let's say you're a coach line and you want to start putting buses on the line, is there a hydrogen supply system in place today that can meet your needs? And I'll start with, who wants to take this one? I'll start with Nicholas again.
Well, I guess, on the vehicle side, yes, so on all the vehicle is covered, the vehicle exists today, they are tested, they're in operation, they are vehicles which have been homologated by the FTA in the US, on Altoona testing, and New Flyer is making those vehicles today. So there's no issue on the vehicle side. You can order them and they exist. There's no technology to be developed. Yeah, it's available. So the supply exists today. Hydrogen, I think the story differs from province to province. I think today you have access to hydrogen a bit easier, more available on the eastern part of Canada than you have on the western part of Canada. There are hydrogen in Alberta. The projects we're doing on the truck projects is sourcing locally produced hydrogen from Alberta. A bit more challenging today in British Columbia, but there are a number of projects in development which will lead to the production of green hydrogen here in British Columbia.
And anything to add to that, Steve, in terms of whether hydrogen can be supplied today for the needs of the bus fleets right now?
Yeah, thanks for that, Mark. Yeah, I mean, for sure, we have hydrogen available right now, green hydrogen in Markham, and we are, actively looking for markets for that hydrogen. And I think I mentioned in my intro slides, there's enough there for 50 at full capacity. There's enough there for 50 fuel cell buses to get started. So yeah, definitely. I think you may have mentioned as well coach buses, if I'm not mistaken, Mark. And I guess the one comment I would make is right now, anyways, I think the technology is more suited for return to base type fleets. I think you'd need a network of fueling stations if you were gonna move into coach operations. Perhaps something like stepping outside of transit into the highway tractor market. Maybe you configure a few stations on the Highway 401 corridor, a major North American artery for trucking, and could probably set something up there fairly efficiently as well.
Good. So if we, the buses are ready, as you said, the hydrogen can be made available, but there's work needed to make it available. Although I would say that there may be some industrial gas companies. I believe there's 4 major industrial gas facilities, merchant plants within easy driving distance of Montreal and Toronto. So some of the industrial gas companies might say that they're more than ready to supply it right now. And I know that the Air Liquide one in Vancouver is actually being expanded as we speak. But let's say we need to be putting hydrogen infrastructure in place. What is the role, in your view, for Canada, for government agencies like NRCan? Why should they be helping in this area, and why? What are the benefits to Canada to starting to use hydrogen for buses and for trains and for trucks, etc.? And what are the long-term benefits in terms of jobs, growth, investment, technology, etc.? And I'll start with Steve. Or no, sorry, John.
Thank you, Mark. Many parts to that question you just asked.
I did.
Yeah, a multi-part question, if you will.
Sorry. Pick your question.
I think in British Columbia, I think there has been excellent support with forward-thinking policy that's been in place, certainly to move forward for this low-carbon transportation business. I mentioned one already, and that's the greenhouse gas reduction regulation that has enabled Fortis to build supply chains right from the production for CNG and LNG through to working with end users, with customers, to put vehicles on the road and connect it all together. The low carbon fuel standard in British Columbia has also helped drive that forward, and there's been a lot of support actively provided by NRCan in making all that move. So layering that onto hydrogen, that same type of support, I think, will be, using that same policy construct to enable hydrogen, I think, is a potential path forward. So right now, in the case of Fortis and the greenhouse gas reduction regulation, expanding various components of that, such as broadening the definition of renewable gas to include low carbon hydrogen, be it green, be it blue, will allow Fortis to produce that in our renewable gas portfolio, right? So that would be a key enabling factor to produce hydrogen wherever in British Columbia. That would make sense for Fortis to do so. That same regulation can enable Fortis to get hydrogen fueled vehicles, such as transit buses, work with agencies to put those on the ground, and then that value chain would link together. Policy levers such as dedicating, well, I guess I should also mention the ZEB policy that's in place now, and some other major policy levers such as dictating, low carbon transportation corridors or areas that would make sense to get hydrogen vehicles on the ground, like policy to make that or enable that would be key. I don't think we've mentioned pilot projects yet, but I think as part of this type of work, just my view anyway, there is a need for perhaps more pilot projects across Canada. I know there's a lot of reference to the very visible project in Alberta, but getting one of those on the ground in British Columbia and right across Canada, it'd be a super way to just climb up that learning curve and just, if you've got a hydrogen Class 8 truck or transit buses moving around urban centers or wherever, it's a fantastic advertisement for this and speaks in practical terms to the success. And actually getting that on the ground would start to link together the value chain and show how this all works. Policy would be key enabler of that as well.
Okay, thanks, John. Now, I should mention, John is going to be stepping out in a few minutes. He has another, he's a popular guy, he's got another webinar that he's going to have to be joining. So if you have any questions, please do put them in there, and I will, I'll put those through to John. I will come back to Nicholas and Steve about some of the policy and the needs that we have for the federal government. But what I want to do now is turn to some of the questions from the audience. And so starting with Steve, for you, I'll put it to you first. This comes from Glenville Singh. What are some of the safety precautions around hydrogen stored on the vehicle?
Yeah, I think I mentioned at the outset I'm not the technical guy.
Right. Sorry about that. I will.
Nicholas on that one.
Okay, I'll turn that over to Nicholas.
No, I think that today it's very well controlled. I think hydrogen vehicle, bus, trucks, cars have been on the road for many years. So there are standards in place, safety on the hydrogen storage. There are guidelines to follow, standards. So I think today it's a very well controlled. It's very similar in a way that when CNG. Hydrogen is a flammable gas, so it needs to be handled on, with care, and there are precautions to take. But in a way, it's a lot of similarities in operation for a transit agency, on the refueling operation and the maintenance, very similar to what you do with CNG. So there's not, what you have seen this morning, very good example with OCTA in California. They have been operating CNG buses. And for the team to move from CNG to hydrogen buses, the learning curve was very small. They're already familiar with handling, gas, flammable gas as a fuel. And so there's nothing really much more to do. Hydrogen is flammable. One of the big advantages is much lighter than air, so it tends to disperse very quickly. So that's a bit of the advantage of hydrogen compared, but it needs to be handled according to safety precautions. And today there are really standards and regulation in place for the storage, for the fuel cell. So it's all the I would say the regulation is in place. So that's why we can build and certified fuel cell vehicle today.
Any special training that's needed for them?
Yes, there are some trainings, and it's done either by the OEM, the bus OEM like New Flyer, by Ballard, and we provide training. I think it's important. We want also to be able to pass the knowledge to the crew, to the people maintaining the buses. So we don't want the fuel cell bus to become that that diva which needs a specialist technician. No, most of the regular maintenance can be done by the transit agency, and it's done today across the world. So we train maintenance technician to do the same maintenance they have to do on a fuel cell bus, electric bus, or CNG buses. And so that can be done. It doesn't require specialists like Ballard to come in a garage and do the bus maintenance.
And another one specifically also for you, Nicholas, was from Dr. Ali Tariq, is what do you think are the constraints in regards of cost using fuel cell buses in the transit network? Is it production, distribution, and consumption?
I think it just, is scale. Is not, it is there. So, I think the big problem of fuel cell bus, if you just want to do one or two buses, the cost of the infrastructure per vehicle is very high. It's going to cost maybe $500,000 or $1 million per vehicle just to build up the station. But once you build the infrastructure for 10, 20, 30, 50 buses, the cost goes down quite a lot. And then suddenly the big impediment that the cost of hydrogen fuel cell buses was at low volume is going away. And, if you take the example of Orange County, it showed that the infrastructure cost of hydrogen actually is lower than the one of battery electric when you start to get to 50 vehicles and above. So I think the biggest constraint is how to start. What do we need? How could we start, enable the transit agency to put the initial buses and then scale up where it will provide a lower cost solution? But at the end, as it was said this morning, it's going to be a combination. We fully see bus depot, and it was really pleased to see the model and John show where a bus can arrive, a bus might be refueled with a CNG and then, the bus with hydrogen, and then you can have a multimodal stations. And hydrogen allow you to do that, allow to mix hydrogen with other fuel. And you have already at SARTA in Ohio, they have the refueling station where the CNG buses and the hydrogen buses come to the same station. Of course, they go to different dispensers, but in the same station, it takes 5 to 8 minutes to refuel, and then they go back to the garage space.
Okay. Thank you.
Mark, if I could just piggyback on Nicholas's comments, I mean, I completely agree that achieving improved cost efficiencies. Scale is really important, economies of scale, and load factor of the facility that's producing the hydrogen. You want that thing to run continuously, basically, to get to lower the unit costs of the hydrogen you're producing. So those are kind of very critical factors. And probably the one other main item, at least as far as electrolyzed hydrogen, is the cost of electricity. So, if you can get at those three items, and there's opportunities for government to help with that, then I think you can get to some pretty attractive pricing.
Sounds good. So, John, if you have anything you'd like to add in terms of, you're going to be a gas utility. Is this an area that you are going to actually provide the fueling infrastructure for bus utilities? Or is that a role that you see the gas utilities could play?
Yes, I think so, Mark. I'm envious of Steve's power to gas facility in Enbridge. It's gained notoriety at this stage. Everyone knows about it. I think Fortis wants to rush to be the second, right? On the West Coast, we're actively working on projects now, not unlike the Enbridge power to gas facility, to establish a base. Fortis would be a party to the project somehow, probably a primary and off-taker to inject and blend into our natural gas network. And while that is not part of the conversation today, I see it as a potential way to develop hydrogen production in the future and to push forward with some power to gas facilities at scale. Even 5 megawatts might seem small, but it produces a lot of hydrogen. So a very interesting dynamic building here in the Lower Mainland right now to bring hydrogen production on stream and build a local incumbent green supply of hydrogen. And in doing so, it'll sow the seeds of the future value chain. Like I mentioned, a pilot project, a strategic, carefully planned pilot project, be it with a transit agency or elsewhere, would start to link together the pieces of the puzzle and thread a nice overall project together. And Fortis's part, or the utility's part in this, at least based on Fortis's experience, we can help enable a number of the steps, be it to enable production, be it to link together the supply, be it virtual pipelining, or contract that, or co-locate our multi-fueling station nearby, or indeed one of the unique solutions we're looking at, research underway, whereby if we blend into the distribution network, blend hydrogen into the distribution network, Fortis operates a number of CNG stations, compressed natural gas stations in the Lower Mainland. The sensitivity of that equipment will require the hydrogen to be extracted from the natural gas. If we extract it, what do? Well, we use it for refueling right there beside our CNG dispensers. So a lot of unique opportunities here. And Fortis, we can play a key part in each step based on our experience operating a low carbon transportation business. To your question about refueling infrastructure, we do that right now.
So taking what you're saying, that you have the interest in supplying this equipment, that there's a number of applications you can potentially tie together, whether that's blending into your natural gas stream, whether that's maybe heavy duty trucking or dispatching somewhere else. Is it reasonable to expect the transit agencies to be having to worry about putting their own hydrogen systems in, or is that something they should really be looking to partner with companies such as yourselves or others, and seeing if they can pool those hydrogen requirements? I'll let Steve tackle that one.
Sure, thanks, Mark. And just to piggyback on the earlier question too about utilities and hydrogen infrastructure, just to lead into the actual question you asked, I'd say that, just as mentioned in my intro slides, Enbridge is an energy infrastructure provider, and we've got a diverse portfolio, including renewables. Some of you may have seen recently our CEO, Al Monaco. He recently reaffirmed our strategy of continuing to invest in both natural gas and renewables. So, it makes sense for Enbridge to play a significant role in providing hydrogen energy infrastructure in the future. In terms of the transit authorities and sort of their role and in this. I mean, I guess a couple things. One thing I'd say is with any, and I touched on this earlier, with any significant energy infrastructure investment, one of the most important factors is utilization levels. So, regardless of the size of the facility, you ideally want to run it at a high load factor for efficiency purposes. So sharing the facility's capacity with other, nearby customers is a great way to do that. So you want to sort of try to, gather groups together to share a facility where possible. Also, I'd say we have experience with CNG as well in transit operations. And in our experience, the transit authorities typically like to focus on their core expertise, which is really efficiently moving people around their municipalities. And they prefer to have third parties own, operate, and maintain the low carbon fueling facilities because it's not their expertise. So I would expect they may want that in this case as well. I don't know that for a fact, but that would be my guess.
Okay. Question from Terrence Johnson. I'll put this to John since you're another West Coaster. Could Vancouver Island be a pilot project for fuel cell powered trains in Canada?
That's a doozy. Vancouver Island be a pilot for fuel cell trains.
And I'll extend that to say a pilot for trains, buses, and etc.
As a location to host a pilot, technically the answer would be yes. If the pieces of the puzzle were to be carefully aligned by someone and suitably packaged and correct funding required to move that forward, then I would say yes. Again, to my earlier point about pilots, it's going to be something I think that we in British Columbia are going to have to look at carefully and implement in the near future. What that looks like, who knows? But yes.
Okay. Nicholas, what do you think about terms of demonstration locations or pilot locations and what we should be looking at to move those forward?
I think it's back to availability of hydrogen. So we need to make sure whenever we do a pilot to demonstration, we have. I don't like the word demonstration so much because we don't need demonstration anymore. I think fuel cell buses and trucks, they work. What we need pilot deployment. So we understand that transit agency need to be familiar with the technologies. They need to operate the buses, to see how it works, to see how it's going to change, alter eventually or not their operation. So that pilot products are important, but I will not use demonstration because I think today everybody knows that the hydrogen infrastructure works, vehicle works. So what we need to do is to create a project which will give the experience for a transit agency or a vehicle fleet operator in order to later on scale up. So that is important to start with. And then hydrogen availability and location is very key. There's no point to start a project where it might be difficult to produce or bring hydrogen. That, why start with making things complicated? There are regions in British Columbia where it might be easier to start. But then when it comes to the vehicles, then it doesn't really matter. The vehicle can be anywhere. So it's really about the making sure there's enough size, and that if we start maybe with only 10 or 20 vehicles, then there's a product to scale up, and then we have hydrogen availability at an affordable price behind.
Mm-hmm. And to Steve's point, also I think it makes some sense that you look at where there's a number of applications that you can pull together. Yeah. For example, I know there's a project being looked at very actively right now in northern Alberta to tie in industrial processing, power to gas, bus projects into a unified group, which presumably will get the hydrogen costs down to the lowest point it can be. And on that question to Steve,
I want to add something on that. Yes, I think it's very important, and there are across Canada, in Quebec or in British Columbia, a couple of projects where you can use some very interesting application like a port, so you can have next to a port, you can have drayage trucks, you can have transit buses, you can have a lot of application which are going to require hydrogen in order to generate the demand that the hydrogen producer needs and guarantee a constant production load.
So I'll take that over to Steve. So looking at the fact that you've got a production facility underway, and you're looking, I think, to pull in the load for that facility, what would be the cost of the hydrogen out of that location?
Yeah, it's a good question. It's somewhat commercially sensitive, so I'm not sure I can share that in detail. But we're trying to get to a rate that can. We have to add some facilities. Our current plant stores the hydrogen at low pressure. We need to build compression and dispensing capabilities, and that comes at a cost, obviously. So. We'd look to recover that cost through the cost of the fuel. But the goal would be to establish a project that can be economic overall for the fleets. It would obviously be helpful to have some level of incentive support from governments to help with that, given that this would be a fantastic pilot. I think Nicholas mentioned earlier, or perhaps it was John mentioned, that having a pilot project available would provide lots of operational data in real use for other agencies to look at. So, that would be my suggestion in this case.
Thanks. My inexperience as a moderator showing through, because I wasn't monitoring my little screen on the side, and unfortunately, Steve had to leave, John had to leave, as was mentioned earlier. But I would like to take this opportunity to thank him for his participation. We have a few minutes left here. Nicholas, what would you say are the most important considerations for a transit agency when they want to look at their choice between battery or fuel cell buses? Is carbon footprint the number one issue? Is it what is the things that they should be thinking about?
Well, at the end of the day, you need to find a solution going to reduce emission, because that's the overall goal, is moving to electric propulsion. However, so that's the number one goal. Make sure that whatever technology you choose, you're going to achieve your emission reduction. But at the end, bus operators operating buses, they are providing transit service to passengers. So they need to make sure that the vehicle they choose is compatible with the service they're providing in terms of range, frequency, as well as aligned with their operation and the constraint they have in a depot: space, energy, availability. So all those needs to be taken in consideration, and not just for 5-10 buses demonstration, but just to say, okay, what is it going to look like when we are going to do all the transition, and then we're going to have 100% zero emission buses at our depot. So I think I will strongly encourage the agencies and the bus operators to look at what it will take to do that transition, to go to 100% zero emission, and what are the constraints in service, what are the constraints from the climate. It might not be the same constraint if you operate in the lower mainland in British Columbia, where it never gets really cold, or when you operate buses in Edmonton, like we have seen this morning. The route and the distance covered every day by the bus. Is it maybe 50, 100 miles, or is it 200-300 miles? So I think all those elements of service are very important, because at the end of the day, they are going to define what is the cost is going to take to provide that service. It means, do you need to have more buses on the road because now you need to stop the buses every hour to recharge them for 10 minutes, or you need more buses to cover more shifts? Do you need to modify your route of service because the vehicle you have doesn't enable you to cover the same frequency or the same distances? Because the last thing you want to do is in the morning to try to realize, oh, bus A cannot do route number 5. So you need to be able to provide that flexibility to the dispatcher. So I think all those operation requirements becoming very important, because at the end of the day, they impact a lot the operating costs of the agency and the level of service they provide. The vehicle needs to be able to provide the same service on a cold day in January, on a very hot day in August. So the first day that the bus is new with a brand new propulsion system, than 10 or 15 years down the road, because the transit bus is on the road in Canada for 12 to 14 years or 16 years. So I think all those elements needs to be taken in consideration. And the last one I want to highlight, sometimes people don't really look at it, is the overall environmental footprint, not in terms of emission reduction, when as a bus tailpipe, but also what is the environmental impact on the technology? What is happening at the end of life? What do you do with the battery? What do you do with the fuel cell? In 5, 10, 15 years. And one of the big advantages of fuel cell is we can be recycled and refurbished. Today at Ballard, we recycle and refurbish several thousand of fuel cell every year. Customers send us a fuel cell, we refurbish it and send it back to them. So I think the total carbon footprint and the environmental impact of technology that we are choosing needs to be carefully reviewed, because we don't want to fix a problem and reduce emission and then down the road create another problem with is disposing of very toxic material. So I think we need to look at the overall picture at long term and at scale.
All right, thank you. I think the final question possibly for Steve, and that is, what do you think is the biggest barrier, political barrier right now to the adoption of hydrogen in transportation and in buses in particular? And when you look at there.
Yeah, I mean, I'm not sure if I'd call it political barrier. I can't necessarily comment on that. But what do we need to build a supply chain? I think a national strategy with broad input from stakeholders. Taking the learnings from other leading jurisdictions like California, Germany, and building on the work that has been initiated already by Enercan. I think ideally with collaboration and cooperation, also with the United States, and ensure consistency in codes and standards and specs and so forth would be helpful there as well. But I think we just I'm not sure I think it's just doing the work to establish that strategy. I don't know if I can comment necessarily on whether there's a political issue with that or not. I think there is a strong will in the country and with our politicians to green our transportation market. So I think perhaps it's just showing that this is a viable way to do that.
Nicholas, would you have anything to add to that?
No, I think it's maybe one thing. I think there's if you take a step back a little bit and look at the objective, Canada has the objective to be carbon neutral by 2050. And I think, at the government level and, all the stakeholders need to recognize that in order to achieve that carbon neutrality, hydrogen is going to be needed. We are not going to do it without having hydrogen as a part of the energy transition. And there are some sectors of the transportation application which are very hard to abate, that cannot be really addressed very easily with batteries. And we're talking about a transit bus operating on longer routes, more difficult routes, coaches, trucks, long distance hauling. All those applications are going to need hydrogen, and as other sectors of the economy. So I think the overall message, political message to government is to say hydrogen is going to be part of our energy transition. We need to invest in it because it's also a great opportunity for Canada, create more jobs. We have a leadership in hydrogen and fuel cell technology. A company like Ballard employs 700 people in British Columbia working on developing and producing fuel cell technology. So this is a unique opportunity that we can seize, and let's put more fuel cell vehicle on the road, and let's use hydrogen as a part of our energy carriers.
All right, and so I appreciate that very much. And just to close off on the questions from the audience, we have Aaron Cook saying, what is the feasibility of developing byproduct hydrogen from industrial applications for vehicle applications?
Sorry, I misunderstood the question. What was it?
It was, what is the feasibility of developing byproduct hydrogen from industrial applications for vehicle applications?
What do you mean 5 products? I'm not really sure.
Byproduct, as in like in North Vancouver, we have byproduct hydrogen from chlor-alkali production.
Yes. Sorry. I misunderstood. Yes, I know, absolutely. And there are some opportunity to use chemical byproducts, and it's done in some countries. Germany, for example, the city of Cologne is getting access to hydrogen at less than €4 per kilogram at the pump because they have access to very low cost hydrogen byproducts which normally is being released in the air, and now it's used to operate a zero-emission bus in a city.
Mm-hmm. Actually, I know for a fact that the liquid hydrogen plant in Niagara Falls is using byproduct hydrogen from chlor-alkali. The liquid hydrogen plant there, the liquid hydrogen plant in Magog, Quebec, is using byproduct hydrogen. So yeah, there's certainly a lot of opportunities for that. All right, I think that's getting to the end of my my time. I would like to thank my panelists very much for their participation today. I think it's interesting. I think I would take from this that there is ample opportunity to supply hydrogen.
Thank you
Thank you very much.
Thank you, Mark. Merci beaucoup. Au revoir.